Hello my friends, Roger once again. Today was stunning news from Caltech authors about cell phones and what their capabilities are, which I have been claiming for years now. They say digital single molecule technology, single molecule, are expanding diagnostic capabilities, enabling ultrasensitive quantification of targets, such as viral load HIV, hepatitis C infections, by directly counting single molecules, which replaces the fluorescent readouts and all that business with a new robust visual readout that can be captured by any unmodified cell phone camera. That's how powerful these new cell phones are. They can see the actual molecules and actually count them, and that is the light that I've been showing. Now don't forget now, this says can be captured by any unmodified cell phone camera. So this is not pie in the sky. Okay, I did show you the thing from Caltech already, which claims that this is fine. These can easily see these and down to the molecular level. This is a huge wave. This is not even close to the range that they're talking about, because people don't understand how big these things are. They own an enormous region. I'll show you a picture I got from my friend Renz, and this will prove it. This is from my friend Renz over there in France, just out doing some French things. I don't know what he's doing, you know. But he's walking around. He decides he's going to take a picture of his thumb. That's his thumb. You have the discs. You see that? And that? That's those light waves. Those are particles of light that are concussing off of his fingertip. And they are literally rolling away. They're being distorted, which makes them concuss and makes them visible to these new cameras. Now, what else you see here? Leptons. You say, oh, leptons, what are those? Blue, green, red. Blue, green, red. Blue, green, red. And then you get into this magenta looking stuff. Those are the lepton colors. Blue, green, red makes everything. Now, there is one additional lepton color they're talking about, but I now believe in these leptons. Now, they say, whoa, there's all kinds of theories about this and that, and muons and taus and da-da-da-da-da. Let's just start from the beginning. That's fine. There's all kinds of things. There's all kinds of particles. See, they're just different sized particles. They don't understand. The light particles, there's nothing to them. We live in this. We live in that light. But the other particles are like hand grenades. They're chunks of atoms, and they agree with that. Now, you should believe me if you trust Caltech saying that these kind of things are capable to be seen down in these ranges. That is coming out of the accelerator. You know, like accelerated light there, Rodney's accelerator comes through here, brilliant glowing plasma, then they begin to reorganize, then they display twice, and there they are right there. Now, what do you see? I see a dipole. I see black, white, black, white, black, white around the circle. And I see spikes coming up and spikes going down. I think this might be capacitive and inductive reactance. That means there's a capacity, which is the bulb of the torus, and there is an inductance, which is the vortex of the two ends of the torus. Those turn into a spiraling, compressing vortex. So you have capacitance, bloop, it blows up out here, and then when it funnels into the neck, it's inductance. It crushes itself, which creates huge reverse EMF, electromotive force, which you saw in the acceleration picture. All those big waves, whoa, 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 come way out, because it exploded when it hit the accelerator. All right, now this is Renz again. Now this is absolutely stunning. There's your blue, your green, your red, your blue, your green, your red, your blue, your green, your red, whatever. Maybe that's the magenta. I don't know. These are the discs, and they are twisting as it rolls off of his finger. He just put his thumb up like that and took the picture. These are the radiations that are coming just around his finger from sunlight. Remember now, this is his thumb. These are the size of these discs. These are not tiny little things. This is exactly what you saw coming off of Renz's finger, but this is in a darkened room, and all of these little white dots in the air are concussed free electrons that are associated to primarily water molecules. And this is what you see coming through the air, and that thing is this big around. That's not a tiny little thing. That's not, oh, it's so tiny you can't see it. No, it's good size. Now, this is when it gets sucked through the Venturi, and it just starts to elongate. It's being accelerated. That's light being accelerated. That is literally the light, though, that little tiny dot. And see it? It could, there's like a million machine gun bullets coming through here, and then they start to stack up at the accelerator, which is nothing more than a Venturi, 2 airplane wings coming in, and it forces it to compress, and everybody violates each other's regions. Because these are that little tiny dot. You see that dot? But it owns a huge region. And they can't force each other into each other's regions without glowing. That's the nature of light. That's the concussion that we see as light. As it comes through here, it's turned into plasma. And then it sprays out of here due to they're all negative, and they repel each other. And I can prove they're negative. There's no question about that. It can be affected by positive pulls in one direction, negative around it pulls it the other direction. So it's a negative particle. But it is a dipole, and I can prove that too. Everything I'm saying I can prove. I have not one single syllable out of my mouth that I can't stand behind. All right, then this is what annoys me, because everybody, oh, the guy's crazy, just leave him alone. Well, no, I'm not crazy, but they leave me alone. Now, it comes out of here, and I'll show you what happens. But all of these are white particles that are concussed due to this enormous reverse interaction. You see them down there glowing like little dots of concussed energy. That's exactly what light is. Now, these are exactly what they look for Higgs bosons. These are the charged particles. They are particles. We know we saw them coming through the accelerator, little white dots. They're coming out of here in those same little sizzling little electrons, and then they smash into the Higgs field, which is nothing more than the free electrons that are floating in space here. And when they do, because they're spinning so fast, they create a polar field around them. You see all these little pulses, and these are all the different colors. And then I'm going to tell you what, my friend, that red laser from the other side ends up being red. You see there's different colors here? Well, why is there different colors here? But they all, when they're done, end up being red. That means there has to be a certain size to them. That's the only thing I can take away from that. And a certain size means it can exist at a certain distance from the nucleus, and that means it can be resonant at that distance and no other. By the way, that's the reverse spinning particle that I think could even be antimatter. That little reverse particle, which is supposed to be the smallest particle there is white. It's smashed into another Higgs field and created this. Whatever that is, I cannot say. Clearly see the right-hand spin of light, which means it drifts to the left. We clearly see it compressing as it moves forward and crushes into the Higgs field, and shortly from there it will present the field. These are the red particles. That's the accelerator, and then they crash almost immediately. They are a dipole, as you can see. There's dark and light. That's no real mystery there. And we see a spike coming up and a spike going down. I believe it could be a torus, and it's rolling around itself in a right-hand rule. As it spins in with the right-hand rule, it gathers energy and displays, and it comes backwards with the right-hand rule. It reverses its energy field. And anytime a right-hand spinning particle turns left, it, I believe, turns into an antiparticle, because it is, as you saw that white particle, and you saw what it did when it concussed. Now, I don't, that's as far as I can go with it, but it started out as the same particle from the same laser. It came out totally opposite, gathering its field, spinning into itself. The other ones were spinning with the right-hand rule, creating fields surrounding them. Then that one crashed with the correct one, and then you had whatever happens. Green responds identical, same particle, only it doesn't concuss until it's much further out because it's got more impact. And I believe it must be a different particle. It must have a more density to it. Because this also is coming through the accelerator. It turns back green. Why does it turn back green? Why did the other one turn back red? They came through white. That's all frequencies. I would have expected it to just come back to who knows what. But it comes back to the right one, so it has to be the same size. And you see Renz's finger, red, blue, green, red, blue, green, red, blue, green. There's something going on with those three frequencies. And they, of course, do create everything. They use those in the TV sets to create every color. All right, I hope you remember this, or if I haven't shown it to you, this is the light wave coming through, just straight through the air, the laser, and the tiniest little beam is in the center. All this is concussion, and it's literally gigantic, this wave. Now, here's the wave being sucked through the Venturi and accelerating, and that is the plasma. That is the concussion and the forced particles to invade each other's regions, and that is why that white is glowing like that. Now, that's a similar effect to a very high energy big particle just smashing into everything in its way. Well, we are forcing these particles to invade each other's regions, so they are trying to escape from each other. In that other particle beam, there's a gigantic bowling ball coming through there, knocking the pins out of the way. That's what's going on there. And the ball keeps going through the center and keeping driving those blue ones, because those are the high energy ones, and the rest are flying off to the side like crazy, getting out of the way. So it's virtually the same thing, only ours is with a light particle. And I mean light meaning very small in weight, and it is actually light, and it is actually an electron. And I believe there are at least 3 flavors of electrons, because we see the identical in green and red. Identical particles, identical reactions. And these are the reactions. And they are the Higgs bosons, exactly what they had expected to get from high energy particles. Identical. This is CERN's high energy particles. They are identical. Identical. Not a single bit of difference. Okay, as always, I'm still requesting some assistance from the university realm on any of my research. And this is what we're going into next is leptons, cosmic radiation interactions, all that sort of stuff. So, please, Roger, R-O-G-E-R, at mudfossils, with an S.com. Email me. Get a hold of me, leave a message on my videos, whatever, but I would like to present this to someone that would pay any attention, because Caltech says this is absolutely no question that these cell phones can pick this up. It's not a joke. This is serious. And it could lead to, literally, to fusion. I'm seeing plasma because of this Venturi crushing these particles. I'm going to tell you right now, I don't think any particle is different than any other particle, except that some of them are positive, some of them are negative, some of them are bigger, some of them are smaller. But they all own regions around them, and if you crush them, they're going to explode. And we have a passive crusher. We don't need to do the things that CERN's doing. We're doing it just by letting it force itself into being crushed. All right? Somebody get a hold of me.